So Starbucks venti size cup is advertised as 20 ounces of coffee. So they're telling us this is what they're claiming. Starbucks is considering purchasing a new machine to fill coffee cups. The cup size is sized so as to hold 22 ounces of coffee and not overflow. The machine that dispenses that coffee into a cup is set to fill the cup to 20.8 ounces of coffee and has a standard deviation of 0.6. So they're telling us the mean of this thing is 20.8 and the standard deviation is 0.6. And it says, if a new coffee dispensing equipment is functioning properly, what's the probability that the machine dispenses less than 20 ounces of coffee? Well, that tells me I'm going like this. I'm going, all right, here's my picture. My mean is 20.8. My standard deviation is 0.6. And what percent are going to have less than 20 ounces? So we're looking for that formula part. So this is going to be the probability that Z is less than, and remember Z equals X minus mu over sigma. We don't have to show that, but I'm doing that here for your help. So 20 minus 20.8 over 0.6. All right. So when I go about that, second bars, normal, CDF, lower bound, negative infinity, upper bound is 20 ounces, mean of 20.8, standard deviation of 0.6. Now I can do that except for the fact that I don't get a Z score. So probably what would be better is for me to go stat test Z test, stat test Z test, and set a mean of 20, standard deviation of 0.6. X bar in this case would be 20.8. I mean, is 20. I said that wrong. Our mean is 20.8. Our standard deviation is 0.6. Our X is 20. Our sample size is a single cup. We want to make sure less than is highlighted. Calculate that. When we get our Z score, which is really important to have. So we have the probability that Z is less than negative 1.3333 equals 0.0912. This is the work I should be seeing, and I really should see the picture as well. Now it says, what's the probability that a random sample of 5 customers has an average? So they're asking for the X bar. They're asking for the distribution of the sample means of less than 20 ounces. Because they asked for the average, I know that they want me to switch from this to Z equals X bar minus mu sigma divided by the square root of N. All right, so I'm going to start plugging in. Well, first I'm going to draw my picture. My picture is essentially what I had before, but now we still have a 20.8, and this is no longer, and this is 20, but this is now a X bar of 20. It's not an X, it's an X bar. So we want the probability that Z is less than 20 minus 20.8 over standard deviation 0.6 divided by the square root of 5. If I go to stat test, Z test, 20.8, 0.6, 20, and now my sample size is now 5, but everything else stayed basically the same. And I end up getting a Z score of negative 2.9814. So the probability that Z is less than negative 2.9814, that equaled 0.0014. Please make sure you're going to 4 decimal places. That makes a big help. All right. All right, the next thing. What should Starbucks set the mean number of ounces on a coffee dispenser be so that 99% of the customers get at least 20 ounces of coffee? So Here's our mean of 20.8. We want 20%, or 20, not 20%, but we want 20 ounces. And we need this area to be 0.99. So what we're really interested in is having 1% getting less than 20 ounces. Because 20% need to, 99% need to get at least 20 ounces. So they need to get more than 20 ounces. All right. So they gave us a percent. So this, when they give me an app, when they give that to me, I know I'm going to be using inverse norm. But generally speaking, I sit there and I write this down, z equals x minus mu over sigma, and I start plugging in to find out what I have. What I have, and it says set the mean number of ounces. What should they set the mean number of ounces? So this, I really don't know anymore. So this is a question mark. So 20 minus the mean, we know the standard deviation is 0.6. And so I'm missing the mean and I'm missing a z-score, but because they gave me an app, I can go ahead and calculate my z-score. So I can go second vars, inverse norm, 0.01, and I end up getting negative 2.326. And this is something that people messed up on a lot because they didn't think about where the 99% was. So they swapped that. So negative 2.3263 equals that, and we solve by algebra. So times 0.6, not plus, minus the 20, and I end up getting negative 21.3958. So negative 21.3958 equals negative mu. All right, so I can make those both positive, and that's my answer. My mean is 21.3958. And if I wanted to check that out, I could go back through and go, you know what? This is now my new mean right here. And I can go, all right, let's do a norm CDF, second vars, normal CDF, lower bound, 20, upper bound, infinity, mean 23.958, mean 21.3958, and a standard deviation of 0.6. And I find out that that's almost exactly 99%. All right, that's almost exactly 99%, which is what we were looking for. So basically, we're just saying, hey, there's my X, there's my new mean. My standard deviation still is 0.6. Okay. All right, so using the mean calculated in part C, what's the probability that a randomly selected cup overflows? Well, we have a new mean. This mean is 21.3958. And if we have more than 22 ounces, we're overflowing. So what we're looking for is what's the probability that X is greater than 22? Well, that's the probability that Z is greater than 22 minus our mean, 21.3958 over our standard deviation of 0.6. And all I did was plug into Z equals X minus mu over sigma, and they gave us our standard deviation earlier as 0.6. So I want to know that probability. So once again, probably the best place to go would be stat, although you can do it as an inverse stat test, although you can do a second vars norm, stat test Z test, probably the best place to go, stat test Z test. My mean, 21.3958, standard deviation 0.6, X value is 22. And then we're looking for a sample of size 1. What's the probability that a cup? and we end up getting the probability a cup overflows is about a little over 15%. So the probability, don't forget to write your z-score, big deal, probability that z is greater than 1.007 equals 0.1569. All right, so that takes care of scenario 3. Thank you for watching.